she got excited. It's the main thing. She got excited more than what I was excited about the whole stuff. So this feels like a win-win situation.
Here in sales for you, actually.
Oh.
So does anyone have questions for Surya? Because
Yes.
I thought it was really interesting.
Suggestion. It was really good. It was really great.
Thank you.
But I have a suggestion.
Yes,
Maybe you tested it. Did you test epitopes against idiotypes?
No, not yet. Not yet. But
Good
I
idea,
think it will be a good idea, yes. I'm gonna try that. There's a lot of things that we are still trying to do, because when we started this idea, it was a super crazy idea, and me and my boss, we thought it's not gonna work. Until the last breath, we were like, it's not gonna work, it's not gonna work. And when I presented in one of the conferences, there was a big shot in my research field. He's like, he didn't agree until his last breath that this thing makes sense. And then I made sure that, we tested it, retested it, and everything went fine, and we published it 2 times. And then it was like, see, now you should believe it. So I'm waiting for the next conference so that I can go and talk to him. And it's like, it works.
Very good. There's another question over here, I think.
Thank you for the presentation, very enthusiastic.
Thank you.
I share your enthusiasm too, for this great product. How long did it take to actually be able to get the data and solve the problem, the whole project? Was it a short period? Was it long? I just want to know.
If you're talking just about the whole project, not about the graph database. The graph database, okay, the thing is that because I told you the more natural way that we think of the proteins is you have a circle of a proteins, it has a pathway and it has a disease. So when I had my first model ready, I think it was quite fast. And I also used PyTorneo, and I used Python. And I love Python, and I use PyNeo, and it's so fast and it works perfect. So I think it didn't take a lot of time, and I don't want to talk about the whole project, trust me. Because it was
With that enthusiasm, maybe.
By the way, she was saying, with Neo4j, everything is always fast. Really true.
till now.
Till now.
I forgot to put a bracket until now.
Exactly, till now. Anyone else have a question for Surya? All right, I think you do?
Be interested to know how expanded or known is the use of Neo4j in academia.
How? You mean how much it's used?
How frequent, what's your perception, grosso modo?
About the Neo4j?
It's known, it's completely...
I don't know. Actually, the thing is that if I talk about my institute, we are the main bioinformatics hub. And when I started working on graph database on my project, my boss is like, we don't have any person who has a skill with the graph database and Neo4j, so go for it. So I think in my department specifically, it's only me who works on it. But we have, so we just had a collaboration with Elixir, and now we are planning to have a small tutorial session so that people know more about the graph database and Neo4j. But yeah, people are more still stick with the relational database rather than non-relational. So,
I think there's exceptions to that here and there. Neo4j actually provides the enterprise edition of Neo4j for free to universities.
yes, it does.
So
I use free.
We're actually promoting it quite extensively in academia. But it's like you said, not everyone knows about it yet, so it's slowly getting more adoption. I do have a funny story actually. So the TU Delft in the Netherlands, Technical University of Delft, like 3 years ago. So when you download Neo4j, it tries to call home anonymously, right? So it tries to contact us and say, I'm here and I'm running a database, and it tells us a little bit about the use. And at the time, like 3 years ago, we had 25,000 running databases at any point given in time, and all of a sudden we had 15,000 more. We were like, what's going on? What's happening? We went from 25,000 to 40,000, and that was the TU 15,000 instances of the FPGA they were running to do like advanced simulations. You know, simulations on energy networks actually. So it was a little bit of a disappointment that they weren't really actually
Paying you?
no, not paying us, but it was more of a with real customers, right? So, but yeah, so it's gradually more academia, but it's slow progress, I guess. You know,
Yeah.
like in the rest of the
Yeah.
industry. Thank you again, Surya, for your presentation. Super
Thank
well done.
you.
Thank you. And I think we have one more, right, Tom? You still have one story to tell. And remember, you cannot be over here. Right? It's not allowed.
That was my spot.
That was your spot. So Tom has also been involved in the FPGA community for a long time. Together with Ignat, actually, we used to do a lot of meetups at their offices in Contig. And he's been working with FPGA for a long time. So let's get it running, which is really interesting.
No, don't need it. Okay. Where is it? Okay.
It's this thin one.
The
And this is the pointer.
Okay,
But
that's
this
the.
is the slide changer.
Okay.
Just forget about this.
Just forget about that one. Check if this is okay. I will put this away. Put this here. Okay. Over here somewhere. Hearing my own voice is also really, really weird. It's the first time I hear it like that. I'm going to talk to you about platforms. We, as Vector, believe in platform business, and it's a way of doing your business. It's not like selling stuff through a pipe. So I build stuff, I sell it. No. A platform is something that creates value from the user. So first, I'm going to tell you the story about platforms and how we believe that platforms are giving the rise of AI. So now you see all this AI machine learning happening, and we believe that these platforms are the enablers of this rise of AI and machine learning. But then I'm going to tell you a little secret. Networks, graphs, are building blocks of platforms. Then I'm going to tell you about a startup where I worked as a consultant, and we built some stuff around things. I did the technical thing. There was other guys who needed to sell it. That seemed to be the hard part because they went bankrupt. So we all as technologists, we think, oh, that's hard to do. That's very hard. I have to think about it. But selling stuff, that's even harder. I think Rick knows that selling the stuff is the hardest part of Neo. It's not the technology. It's not the thing that's really hard. So what do platforms do? They allow users to create value, and they provide services that other business things can do stuff on top of it. Can give you some examples. FaceMatch, that's the first thing that Mark Zuckerberg did. We now know what he did after that. You know where it came from? He's giving scores to fellow students. So this guy is not good. His morals are really weird. So now we're surprised that they're selling data. Okay, if you see this one, then other platforms, Amazon. What's the platform there? You rate your stuff, and the ratings that you give enables the platform to do other stuff with it. We see LinkedIn. What do? You send your contacts. It uses your information to create value for other people. That was what a platform does. We all imagined PageRank here, Google. What does it do? Websites provide information on what is interlinked with each other. They use that information to create a service around it. Also, it's a platform. Your phone is a platform. It provides APIs to app developers that can create all sort of applications around it. So a platform also creates APIs that you can work on top of it. So how is these platforms are fueling the AI revolution? I'll show you. So on Amazon, you give reviews to certain items. What do they create from that information? They create recommendations from that information. So the whole system about recommendation systems is fueled by your information. LinkedIn, what do? They get your context, and they do the little try closure thing on the graphs. So if you know two people, there's a big chance that those two people also know each other. That's what it does when it recommends you persons that you may have known. Because you choose, I know this guy, I know this guy. And what it's based upon is probably you're walking around in the world, you see that guy and you see the other guy, and probably at the same venue. So that's how they get to know each other. So these things, giving information, they are fueling the AI revolution. Now Google is also doing something AI. So they started with PageRank, some searching. They created Android, and now they're going on to the conversational UI thing. So it's, for me, it's more intelligent search. It's more another interface on searching stuff. So that's fueling the AI revolution. But you know what all these companies have in common with each other? All right, guys, you know it. Graphs. They're all built on graphs and networks. If you see Facebook, it's a social graph thing. LinkedIn, social graph. What's Amazon doing? It's creating recommendations. The recommendations are built on graphs. You use this content-based or item-based filtering, what you link things together, you start searching, it's a graph. The knowledge graph, it's the things that instead of PageRank, there are more information. All this information is getting you a really big knowledge graph, and that's what you're providing your search results. Now I'm going to tell you about a little startup. What did we do? We tried to build a platform, build around a network, a graph. The problem that we tried to solve was, in a company, you have certain data stores, data all spread around, and you have certain personal information in all these data sources, what I call the data diaspora. So the problem is that in this data source, my accounting data is like this, in another one it's something else. So what we wanted to do is want to create one view on that person, but the problem is that I'm stored in different systems with different data. So you see, we have 5 persons, my wife is included in the database, and all this data doesn't match. You have to search for my Twitter handle is sometimes the same, so, and you have this spread all over the place. We take it together and we start doing matching. But the traditional approach of matching is very hard because it's a combination without repetition. What it means, if you get 100, it's okay. 1,000, it gets bigger, 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 and it gets bigger very, very fast. So if you start to compare all these records together, it's not going to happen. It's not, because it's too big. It takes too long. What if also if I don't want to find the other records, but I want to find other social structures like a household, or I want to find a community, I want to find a street or something like that. These things are always really hard to find when you're only matching stuff. What if you want to do it online? So I get a record coming in, I want to online check it with all my data sources, and I want to say, okay, this is the same record that I have is in this data source. It's also very hard because I have one database. What are you gonna do? One of the solutions there is we create an index. We do some lookup somewhere. Then again, that's the only solution of finding my other record, but it's not finding my other household, or it's not finding my community or something like that. Another solution that you can use is when you have a big pile of records, it's what they call blocking. And then you say, okay, I'm going to put little blocks in there, and then I'm going to compare all those records together so I can get this big size, I can get small, make it a little bit smaller. But then again, we wanted to do something fancy, and I wanted to use some Neo4j and some graph technology in the project. And so what you do when you hire a consultant, he comes in and he gets all these nice stuff that he wants to try and put something together. But now it also happens to do something really good at the end, because we were able to go through all these records, and even if I go through my wife or my kids leave a digital trail, I can compare two records and I can do some graphy stuff with it. So how did it happen? We store it like this. We normalize the things like email, Twitter handle, so they only get created once, but then the personal information in every record is created for every record that's in there. Now if we want to make a comparison, the only thing we have to do is traverse the graph and check for every record that we can compare with each other. And now I can compare my point A with my last point, and I know that there is a strong path between those things. So if the name is the same, probably it's the same person, because my wife left some trail somewhere, my kids left some trail somewhere, and I can compare these two together. And if you take the whole thing that we have there, we have a household kind of system. Now we did some graph algorithms around it. So the thing that we use is the Tarzan algorithm to find connected components. And how did we do that is by cutting off certain relationships, and then we get these islands that we needed to traverse and find these other records that are similar to that. If we found these islands, we put an extra node on it, and then in this extra node we call it a connected component. We left some other information on how much records were there and things like that. There's a very nice thing that happened is before we had these kind of stored procedures in Neo4j, you had to really go into the server and things like that. So now you have these stored procedures, and APOC procedures are one of the libraries around it. And I created my own algorithm in it, and I contributed it to the APOC library. It's not multi-threaded, it's single-threaded, so it's not really fast, but it's reasonably fast. Because now you see they are starting to get these more multi-threaded algorithms in there, and that's where they get the speeds going up. But it's a simple algorithm that goes through the graph and starts connecting all these things together. So it was a nice experience, because you can row level in this thing, and you start really hopping from node to node and doing stuff. So it's fun to do. And what's really important, I talked to you about the blocking thing. If new records come in, we create it, we denormalize all these email, Twitter, things like that. We have our starting point, and then we start just hopping around and collecting. So you don't need to block. Blocking is naturally, because it's data locality. You just get into the graph, start hopping around, comparing records with each other. So, but why my story about platforms before is, what our thing we wanted to do is, we wanted to do not this only for a customer with several data sources, we wanted to do it over other customers, where they can contribute to the network. So if you have customer A with all these records, it gives them hashed or pseudonymized somewhere, but the only way that we still can make these connections, we can go over data of another customer and find a path that we can say, okay, customer A, you have two records. Because we go through a link to another customer, can say that this record is the same for you. It's the same person. You don't have the data to prove it, but we together with several other customers, we can go through this path and we can say, okay, these records are the same. And we can do this in a secure way, because we don't need the real names. We just need values, hashes, or things like that we can compare. We can say it's okay, it's a path, it's a strong path. We don't know the data that's in it, but we can say that these records for you are the same person. So that's what we tried to sell, but didn't sell. So sorry, that's my end of my talk. So if you have any questions, I can answer to these questions if you want. Technology works, the selling. That was the hard part.
What was the name of the algorithm that you developed?
Tarjan. Tarjan.
And what does that do exactly?
It's it detects weakly connected components, strongly connected components in your graph. But I first thought of it as a batch approach, so I wanted to take the graph and then detect all these components, but in the end, we did the online approach where we just jump in and do things like that. So probably with a breadth first or a depth first search with some tweaking around, it should also have worked, but it was nicer to take an algorithm that somebody described and then build it in the APOC procedure and then contribute it to the thing. But the APOC procedures, the last 2 years, they advanced so super fast. It's incredible because in the beginning it was just the old way of hopping and things like that. But then there came the guys contributing these multi-threaded things, and then all these things start happening. It was really nice. It's open. You can just download it, check it, learn from it. It's very nice.
I'm not going to tell you how Epoch got into the product, because that's a little bit embarrassing. Well, the short story is that our product management said, you know, that's a bad idea, it's a bad idea, we shouldn't do it, we shouldn't do it, we shouldn't do it. And then one of our engineers did it in a weekend and got it into the product, and now it's like the most used part of Neo4j.
It's like the big data technology. Spark got also written in 2 or 3 days, and now it's one of the biggest.
There's nothing like an itch
Mm.
to start scratching, you know. Anyone else have a question for Tom?
So if again had the opportunity and you knew that you would have, does it work now? Yeah. So if you had the opportunity to start again, and you knew there was no market for it to be able to sell, would you again try to tackle the same problem or?
But I think there is a market. I think that there are already companies doing these, like these big data brokers, but in Belgium, so the problem is that the idea of the platform business and the things that interlink the data, that's something that we as a technologist wanted to sell. That's not what the business people wanted to sell. They wanted to go to a company and say, I can take all your data and make it clean for you. But that's not, we wanted to sell a platform where you can combine all these companies together and make these things. And then if you have these data and you can add extra stuff to it, that's the future, I think. But it's dangerous because I don't know if Belgian companies want to give data to their competitor or something like that. So it's hard to sell too, but
I think it's more about the quality of the. Inside it. Can you hear me now? No? Can you hear me now? Yeah. Yeah. So I think it's because of the privacy of the data. Right?
no,
The
but
copyright and the privacy.
because in the idea, the data that goes into this platform should be anonymous. You shouldn't be able to get the data. We should only, what we need is these paths and how these paths, and we link things together, but we need just to know these paths. If there's a hash value somewhere in that path, I don't need to know if it's an email or something. I just need to know that this is a unique thing. And then I can see the path in it. I can tell to the other customer, I found a path for you that connects these things together. And that's probably the same person there. But the platform in the middle doesn't know anything on what is in there. So that was the idea that we wanted to sell, but didn't work.
But I think we can be loud. He said it's not going to record this.
Mhm.
I think, I mean, if you try this, like you said, you can do it in different companies. But I think there are companies which has different departments itself, and they don't know about each other. They're still struggling with the data management stuff. I mean, like I said, I mean, there are really huge companies who have never thought of managing their data, and now they have departments. So I don't think it's a problem of like companies sharing their data. If you focus on one big company which is really old, like 200 years, go for it. Trust me, they have data management problem and it will solve, I guess.
But the thing is that we created the technical matching engine and the things around it, but they also sold data quality stuff and other processes and cleaning of data, people doing that manually, and that's not what we were focused on. This is the little part we created it, sell this one, not all the things around it, but
Yeah, but then that's the thing that you have when you're talking about the first step, you need to also consider the first and the second step. If you are not dealing it, maybe you collaborate with somebody else.
and the thing is that what is in a startup is also funny is that in 2 years you pivot a lot, and then you're building this, and then they say, oh no, stop it, no, do this. And then they demo it for the management and said, oh, but wait, 6 months ago you had a dashboard on it. Where's the dashboard? We didn't provide it anymore. Okay, we built a dashboard on it. So this goes on like this the whole time. So it's very nice to learn how it goes in a system like that, and it's been fun to be part of it for 2 years. So
It's about the journey.
yeah. And then you have this team together that's really good and doing stuff, and then they said, okay, no, stop it, team.
One more question, and then we'll adjourn. Unless anyone wants to adjourn already. I think we're done.
Perfect.
Thank you, Tom.
Thank you.
That's it for tonight. I hope you had a nice evening. If you want to hang around for a little more, please do. We are going to wrap up in 10, 15 minutes because these guys need to go home as well. So, thank you for coming, and I hope to see you next time. Cheers.
Sorry guys, so see you soon, see you later, and thank you. you for watching.